All right, everybody, welcome back to the Aurora Space Program Extras series. In this series, where we go over all of the vehicles, planes, rockets, whatever we created in the previous year of the Aurora Space Program series. Currently, I have 1955 and 1956 published. I did a bit of maybe a little bit of a favor, I guess, and I published 2 episodes in 1 week. In 1956, we do make it to orbit. 1955 is largely the very beginnings of that lead up to orbit. And what we're going to do is we're going to start off with the planes as we usually do. Here we have the Kawuk XJ03. This is going to be the last of our original test bed for the Aurora Space Program. The X-Jet program is rapidly evolving, obviously, and this plane, largely designed for a time period that has since passed, is starting to become a little outdated. The Delta Wings, they have proved to be very successful in keeping this plane going, but we're going to need something a bit bigger at this time to be able to further advance our projects and aims. So we're going to go back over the XJ3. So largely the main difference between this and the XJ2 was the new engine. So this time we use the J48 turbojet, and we have these drop tanks on the plane. Now these drop tanks, you don't necessarily need them. However, I found that when I was trying to hit new Machs, new speeds in the high supersonic range, I needed that extra fuel to be able to push the plane up to a certain height, where reaching those speeds was not outside of the realm of possibility. So this J48 turbojet is it's a nice engine. It uses an afterburner to get up to speed, and it was pretty capable, I think, in our episode. But obviously, all things are going to come to an end, and this XJ3 plane is largely going to be relegated to a trainer in the future. It's just not capable of pursuing the contracts that we require it to for any more of our X plane program. And one thing that I did want to note is, even though the completion of the X-Plane program is still somewhat in the future, don't think that that will be the end of X-Planes on this program. We'll always have these basic X-Jets, but for rocket planes, that's going to be where it's at. We're going to be spending a lot of time on lifting body technology in the future, and trying to develop things that would lead up to a space shuttle. But for now, we're still stuck with these simple jets and simple rocket planes. All right, I'm going to move on to the X3, and I'll talk a little bit about that. Um, there wasn't much to cover for the XJ3, so we'll see you in the next plane. And welcome back. Here we are with the X3. Now, there are some obvious changes that some of you may notice right away. Those being these RCS units. We have some little altitude jets that are to help control the X3 at higher altitudes. Above 40 kilometers to 50 kilometers, it becomes very difficult to use control surfaces in the upper atmosphere, and so our planes required a measure, I suppose, to increase their capabilities up in those altitudes. While the X2 cockpit can take us up to 75 kilometers, I don't think control surfaces would be able to actually work at those heights. So we decided to add some, I say me, I decided to add some attitude jets. These ones on the wings power the roll control and also assist with the pitching of the plane, though it is a little bit difficult considering the center of mass is much closer to them. So these are typically going to be our pitching motors, but these ones are primarily for roll, and I decided not to include any yawing motors. These are largely just to assist with keeping the nose in line Just a slight yaw they provide, but there's no dedicated yaw motors as there are the pitch motors. Um, for the plane, the RCS fuel is stored in the cockpit. All the extra space I had, I filled it up with nitrogen. And then the rest of the plane is largely made up of fuel. And it is fuel for a new engine that we have on this plane, that being the XLR 25. So, the XLR 25 is a great engine, and truthfully, it is the primary engine that you're going to use up until the XLR 99, which is the X-15's primary engine. The XLR 25, a lot of people have difficulty with it. It does have a limited number of ignitions, but that's okay. You can just refurbish your planes if you run out of engines. I had already been doing that with the X2, with the XLR 10 or XLR 11 engine that I had one ignition. But the XLR 25 is extremely powerful. As you can see, only a single engine can get this plane up to a thrust to weight ratio of 1. And before, I was using underwing engines to assist with the speeding up of our plane, which I no longer need. This plane is fully capable of propelling itself, and the further you go and the longer you fly, the better the propulsion of that engine. However, however, you must take into account one thing. Let me turn on RCS build aid. This helps me a lot better than the uh, center of thrust overlay. There you go. I don't know why I was struggling with that word. Notice how these engines, there are two nozzles, and one is pointed upwards and the other is pointed straight out. As default, by default, this engine will be pointing straight out and the other one will be pointing upwards at an angle. That is going to be extremely bad for your plane if you are not paying attention to that. At higher altitudes, when the control surfaces cannot hold your plane attitude, you are going to be struggling a lot. So you want to make sure, and I say this every single time I use an XLR 25, I do this. I pull up RCS build aid. I'm going to do a quick maneuver here. I'm going to show you what it looks like by default. There you go. See how the plane, it wants to pitch upwards extremely heavily. Um, so what you'll want to do is you'll want to go to your rotation. I swap between rotation, offset, and place tools by using 1, 2, and 3 on my keyboard. And you click on this part, and you want to go down to the circular. You want to turn off the snap and pull your mouse as far away as possible, because that means the amount that you move gives you less of a degree of rotation. And you'll want to rotate this engine until it disappears, until the rotational torque disappears. And then you can also double check your work if you have more than one engine, or if you have more than one fuel tank, by turning down your utilization and seeing how big the torque is as you go forward in the flight. So see, I turn down the utilization because it's easier than just going boom, boom, boom. But some people might do it differently, or they might use Filler Up or whatever, the app that lets you check your fuel your fuel amounts. But here we go. I'm going to slowly. There you go. See how it's got a little bit of torque still? Now that should counteract that bit of torque that I saw. Not quite as good as I thought it would be, but it counteracts the torque just a bit. Anyways, so you want to make sure that with this XLR 25, I don't know why I want to keep saying RS. It's not a Soviet engine. Um, you'll want to make sure with this XLR 25 that you counteract the torque that it's going to give you. These RCS jets, your early RCS jets, are not going to be strong enough to actually be able to pitch your plane down. I mean, even if you went up here and you grabbed these massive, or like 5 jets, I guess there's a bigger one, right? Yeah, if you grab like the 5 jets, it's not going to work. I've done that before, and it's never been able to counteract the XLR 25's rotational torque around the center mass. So you'll just want to make sure that you try to negate it as much as possible. Um, and your RCS should be able to counteract a minor torque, but it won't be able to do it all. So I guess that's it with the planes of 1955. I'm going to check and see if there was any that I missed, and I'll be back with the next plane. All right, so this is our last plane that's going to be featured in this episode of Extras, and this one is actually only debuted in 1956. This is the callable X3DT, which stands for drop tank. And it utilizes 2 small drop tanks for this rocket plane, excuse me. And these drop tanks, they're largely to get it an extra boost in height as it goes up, up, up. And it gives it that extra kick that allows it to get through the lower atmosphere, and these are designed only to stay on through the lower atmosphere. The reason that is if I go back to RCS build aid, you'll see we have massive rotational torque. If I take them off, the torque is no longer there. So once they are dropped off, the torque goes away. But during the lower atmosphere, we have enough control authority with our wings to be able to counteract that torque. So that's the only reason that we would utilize these drop tanks in the lower atmosphere. If you ever wanted to have drop tanks on in the upper atmosphere, you're going to have a little bit of trouble because your RCS obviously is still not going to be able to counteract the torque, and it would offset your center of mass by far too much to be able to actually uh, utilize them effectively. Um, so I think that's going to be it. This is the last plane. That was the only major change between the X3 and the X3DT was the drop tanks. And so I'll leave it at that. And next we're going to go to the rockets. All right, so welcome back here. We have the Ahote 4 bumper. I'm almost certain that I covered this in the 1954's extra video, but I'll give it a little bit of a cover here. So this is just the Ahote 4, a pretty standard variation of the Ahote booster series up to this point. And it just takes an Ahote 2 or an Ahote 3, one of the two, and puts an XLR rocket on top of, or excuse me, an XSR rocket on top of the stack. And this was designed with the hope or the intention, maybe even, of trying to complete the downrange contracts for the Aurora Space Program. And while I never picked up the what do I call it? The suborbital rocket development program. If I had, these rockets would have been the ones that would carry out those contracts, and that was largely my intent with these rockets. They never managed to work, so I never ended up picking up that program because I felt it was a waste of time and a waste of reputation and confidence to try and pick up that program when I didn't have rockets ready to actually complete it. So here we are. We've just got a nice little launch base, the same one that we've been using for most of the Ahote rockets, and we use the Ahote 4, and this uses an A4 engine as its first stage and an XASR. Let me just check that. XASR2, I believe. Yep, XASR2 engine as its second stage with a nice 50 units of sounding rocket payload and a basically worthless probe core on top. It's basically a dummy rod meant to expend all of its fuel and launch itself downrange with the minimum weight possible. Um, but yeah, so that's it for this launch vehicle. I'm going to hop on over to the next launch vehicle and the last launch vehicle of 1955 that was new. All right, and here we are. We have a bit to go over here. This is the first of the 100 series of Ahote boosters. Um, when I developed this series, I had in mind that I was going to utilize a series of boosters essentially derived from the original Ahote boosters, and I was going to use them to eventually get myself to orbit. And while these boosters would not take us to the moon or to any of these other places, these would be a great test bed to get us to that first steps, those first orbits that we can use. Um, so here we are. We've got a booster. It weighs about 28 tons. It's a nice size, but we have a controllable mass of 34. I created these procedural avionics with the idea that future boosters would increase in size, and so I put the controllable mass up to the maximum of my launch site at the time. So that way, when I did increase the boosters in size, they would um, they would demonstrate a stronger capability each time, and I wouldn't have to update my avionics and then spend money on tooling. Same thing with this upper stage. I only expected it to control 4 tons, so that's uh, that's all I left it for. So beginning with the bottom here, if we toggle this fairing open, we utilize an NA75 110 series engine. Um, I don't know if you remember, but I believe in 1954 or 1955, I did an engine test stand with this engine because I intended to get some data units before I launched the Ahote 100. Now, that didn't happen. The test stand obviously failed, and it was my own fault for not doing a little bit of research and understanding whether or not a test stand actually works in Realism Overhaul. They do not. Um, but I still have enough data units to fly this engine. It's at about 91% reliability, considering it's the only first stage engine. If it failed, I would just be able to roll it right back and repair the engine. Um, so it didn't really matter too much to have only one NA75 110 engine. These are the early Redstone engines, and I can't remember exactly, but I don't believe I go any further with these Redstone engines. They are just far too weak, I think, for later launches and far too unwieldy to try and utilize. But they do make a good stopgap measure in between the A4 and later engines that would actually take us further into space. But moving on from that, we have the second stage, which if I go ahead and zoom in a bit, I'm going to detach this first stage and we'll look at the second stage. This utilizes a very simple system. Um, you have the AJ10, a version of the Aerobee, the AJ1027 engine. And while that can only fly for about 52 seconds, that's totally fine. We only needed it to fly for a minute, I guess. And I was trying to push the limits. Let's see what its rated burn time is. So its rated burn time is 52 seconds. Does it have a tested burn time? It does not. Later engines do have a tested burn time, but either way, I couldn't do much about it. This was the only engine that I had at the time that was capable of flying for any extended period of time and also igniting off the test stand. So, in order to make sure that the engine ignited, I included these little modular nitrogen-powered RCS thrusters These thrusters would be utilized to speed up the rocket and settle the propellant at the bottom of the tank, so that way the AJ-1027 could ignite. These thrusters at the end of these booms would be responsible for maintaining attitude, since this version of the AJ-10 does not have any attitude control. They also would be responsible for rotational control. And then up here is our little nitrogen tank. It doesn't have a lot of nitrogen, but you don't need a lot of a nitrogen to actually maintain attitude on this rocket. And then within our fairing, we have the next stage. This is an AJ-1027 as well, but it was meant to hot fire. So basically, as soon as this engine stopped burning or was about to stop burning, this engine would hot fire. I don't believe it ever worked, but I guess that's just how the cookie crumbles. That's just how it happens from time to time. This never worked out, but it was supposed to hot fire and take this stage a little bit further. It had about a minute of burn time, and it was supposed to get it just a little bit further up. And these rockets, once its engine had burnt out, once all the fuel was exhausted, these rockets would be ignited and it would spin up the stage, and then it would launch on top of this Aerojet 2.5 KS solid rocket motor, and that would bring our Taean, early Taean satellite um, to a long downrange capability, or to a long downrange place. So even though this it didn't work, I mean, like, this was largely a test bed for future launch vehicles. Um, it was still a great test for all the parts that went into making an actual orbital launcher. And you can see this solid rocket engine isn't really ideal for what you would want to use in space. It doesn't have a really high vacuum ISP, and it doesn't really have a high thrust, a high delta V. So yeah, I think I move on to later engines, and so that was it for 1955. I'm gonna bring you to the Ahote 200 now, and I'll be right back. All right, so here we are back with the Ahote 200 this time. The largest difference, I think, with this rocket would be the first stage. Everything else is going to be pretty much the same. It utilizes the same upper stages, but the spin motor and the hot-fired AJ-10, um, because all this was supposed to be like a dummy rocket, essentially, because none of this had probe control. And this AJ-10 down here is largely the same, very simple. But down here, we extended the booster a slight bit, and we are now utilizing that engine that I told you that the NA 75-110 was a stopgap for. This is the LR-43, except it's the XLR-43. Um, and that is an early version of the LR-89 engine that would power the Atlas rocket to orbit. This engine would be our first real orbital class first stage engine. I'm sure you could do it with the A4. I'm sure you could do it with the N8-110-75 or N8-75-110. But yeah, I think that this is the first one that really shows promise as an orbital rocket. So, of course, in our tradition, our usual tradition, we have a rocket engine that's designed for a certain burn time, rated for a certain burn time, and we push its limits. We have 1 minute and 29 seconds worth of burn time. We also might have done some upgrades. I'm not sure. No, it's just a regular aluminum fuselage. Um, haven't gotten to the upgrades, I guess, yet. And this engine is quite a beautiful one, but we had to hide it behind this aero shell just to protect it from, I don't know, the aerodynamic forces, I guess. But Yeah, so it's a pretty easy engine. It also has gimbal. It's one of the first engines that we have that have has gimbal on it. And at this point, these fins that I have on the rockets are starting to get a little bit redundant, but they do provide roll control, which is really important. So I left them on for the time being. But that is the Ahote 200. This was our first rocket of 1956. And we're going to go on to the next rocket here. And welcome back. Here we are with the Ahote 300. Now, this is the last design that did not go orbital. This was a design that I actually intended to go orbital or very, very close to it. I wanted to see if I could at least get a periapsis above the Kármán line. Um, but we never were able to do it. It's actually quite crazy. I had been reading Delta V maps, and Delta V maps typically said that you need 9,000 meters per second to get orbital around Earth, and that is around a 250,000 kilometer um, apogee and periapsis. So, or 250 kilometer, not 250,000. That'd be crazy. But around that height, you need 9,000 meters per second to get to orbit. And I was like, oh, well, I've got 8,055. That's really, really close. I mean, maybe I'll get a perigee above 100 kilometers. Well, no. The way that you can do it with 9,000 meters per second of delta V is by using coast time. So, like, um, you you don't ignite your final stage until you get to your apogee or whatever. You have to calculate in the coast time of your rocket while it coasts up towards its apogee. Well, I didn't know that. So I invented this little rocket as designed to go orbital. It was designed for that. And it almost changes nothing. So on the first stage, we still use that XLR 43 engine. The stage there is the same length. And then up to the next stage, we still utilize that old AJ1027. And I'll show you that just for proof. It's still nestled within those RCS booms. And then on top, we still, or we don't actually, we use a new engine, two GCRC 33KS engines. Now let me go over to our engine tab. Don't mind any of this. This is a bit of a spoiler. This is a very simple kick motor. So you can see it was used on the third stage of all but the last Vanguard launches. It's pretty good. It says it has a burn time of 33 seconds, but no doubt these show 21-second burn times. Um, and they are pretty great. They are really good for utilizing, like trying to get up into orbit. However, because this stage was a dummy stage, I had to, on my MechJeb ascent guidance, calculate in a fixed coast length of only 0 seconds. And that what that means is that the rocket will ignite one stage after another, and it'll go stage by stage by stage until it reaches orbit. And it'll plan for those fixed coast lengths. The only problem with the MechJeb ascent guidance is it doesn't know that you don't have avionics on these upper stages because it assumes, I believe, based on stock KSP, that all probes have some form of avionics and they have some form of reaction control system. Well, obviously, you don't have it in Realism Overhaul, and these last two stages are dummy. And in order to keep them going straight, I added these little spin motors. Very simple. It's designed to pop off from the last stage and spin up, and then ignite each of these motors in sequence, one after another, and then drop off our little procedural probe core in orbit. This is a early TAN satellite, and I mean, all these satellites were designed to go to orbit. They had no, I guess they had no, mm, potential to stay very long up there, but they all had all the experiments that I wanted to get completed on board, should they have made it to orbit. And it looks like I probably could have saved some weight. I guess no, no, okay, it is on a science core thing. I thought this was near Earth avionics. So I was a little confused. But yeah, so this is a pretty simple rocket, very simple. It was used to get me to orbit, and or it was about to be used to get me to orbit. But that's it for the Yohote 300. I'm going to go on to the final rocket of 1956. All right, I must admit, I'm a bit embarrassed here. I seem to have saved over my previous launch vehicle for the Ahote 400, and I saved it with an Ahote 500. So, I would say the largest difference that we experienced between the Ahote 400 and the Ahote 300 was that there is an extension of the first stage. I extended the first stage up to about what it would be for this Ahote 500. So you can just imagine um, the rest of the upper stages were the same. This is a different rocket, so I won't go over these upper excuse me, these upper stages until I do the extras episode for 1957. Um, but from the bottom stages, we'll be pretty comfortable being able to go over these. It just utilizes the same XLR 43 engine, and I extended the lower stage by around a meter or two. And I remember that got me up to about 94,000 or 9,400 meters per second, somewhere around there, 9,300 meters per second. Um, and I believe I extended the AJ10 stage very, very, very slightly, if at all. It was very short, uh, but that got me up to around 9,400 meters per second, and that was what was able to get me to orbit on the second flight of the Ahote 400. Um, I think that was a pretty successful 2 years. I was very proud that I was able to get to orbit almost a year before the Soviet Union did it in real life. I know there's faster ways to do it, but I've never ever done an American only tech challenge. And um, it probably could have been done much faster had I used Soviet technology, because usually I'll have some of those early Soviet engines that make up an R7 by like 1954 and 1955, and I'll be able to actually utilize them on orbital class rockets very quickly. And in the past, when I've done RP1 saves, I've actually managed to make it to orbit by about mid 1955. And I'm a little bit ashamed to say that it took me the whole entire year of 1956 to actually make it, um, since I had assumed that 9,000 meters per second was what you required to get to orbit. And I'm not sure why I didn't press the simulate button in the corner and actually figure that out before I rolled out in a Hote 300. But I guess that's by the by, and can't be undone. So we wasted a couple months, but I think that's something to be learned from. So if any of you are watching still, and I know it's kind of a long extras episode, I would say make sure to learn from that. Always press the simulate button on this integration info tab up here. Press that simulate button. Try and see if your rocket can make it to orbit before you actually waste the money. And I mean, it doesn't cost much. This rocket wasn't very expensive, but I mean, your math may be wrong. And I guess that's just how it happens. And in some ways, I think that made a bit of more authentic space program feel. I was attempting to reach orbit based on information that I had at the time, and like things evolve and you learn, and you never go back and make the same mistake twice. Uh, but it could have been improved, and I guess like y'all can learn from that. Take take the knowledge that I missed out on during my playthrough. But I think that's going to be it for this. Excuse me. Breathed in wrong. I think that's going to be it for this Aurora Space Program Extras episode. You just want to make sure to take all the right lessons from this to try to advance your own space program. And um, I will say another thing, something that I uh, I learned very quickly in 1957, as our space program very nearly comes to an end. I'll leave that as a bit of a spoiler, a little bit of a little tasty treat, morsel there. Um, Something that I learned in 1957 was that you don't want to waste the early years of a program on development. Try to develop your vehicles ahead of time, and you that way you have as much time as possible over the course of a program to actually complete its objectives. 1957 is going to cut it very, very close to the line um, for the survival of the Aurora Space Program, and it will be really a bit of a buzzer beater, as it were, before the program expires for light satellites and I run out of funding. And without the successes that I do have or the failures, I mean, we may not have that many more episodes left in this series. So when you're doing light satellites, especially when you're doing light satellites, and especially if you're doing it on breakneck pace, make sure that you develop your vehicles ahead of time. Like in the early years of suborbital development, I should have had some of these Ahote boosters out ready to go. So that way, as soon as I got my light satellites contracts, I could actually launch the probes. And I was largely spending money from that program on development of the probes and not development of the rockets. Um, and I suppose that's also what suborbital rocket development, the program, is meant for. But uh, definitely keep that in mind. And so, yep, that's it for the Aurora Space Program Extras. This is 1955 to 1956. So we've covered vehicles from both years. 1957 is going to be interesting. I have a couple satellites that I'd like to go over and talk about their makeup and whatnot. Um, and yeah, we'll see y'all in the next episode.